Okay, welcome back to proofs, coordinate geometry proofs. We're back on page 191, and we're going to look at both parts of problem number 2. All right, so it says, if the quadrilateral below is a rhombus, what is the coordinate of R? Show how you get it and say why your method works. So again, here's our hypothesis. The quadrilateral is a rhombus, so we're assuming that that's true, and then it's saying find that coordinate. All right, it's told us H, O, and M, the coordinates of them. Now we're trying to find R so that it is a rhombus. Okay, so there are a couple different things that we think about here. Again, we're looking for an X coordinate and a Y coordinate. And we know that a rhombus is a parallelogram. So one thing that we're going to have to say is that the opposite sides are parallel to each other. So these two sides, RH and MO, have to be parallel, and HO and RM have to be parallel. So if I can find the ordered pair, X and Y, that makes both these sides parallel and these sides parallel, we're good to go. Okay, so let's take a look at this. Hopefully you'll notice that these are going to be a little bit easier, because if we look here, we would say that we have to find the slope. So slope of MO is going to be the difference in the y coordinates, so 2 minus 2, over the difference in the x coordinates, 8 minus 3. So we end up with 0 over 5, which is 0. Right, that means that this side is also going to have a slope of 0. So I'm just going to call this x and y for right now. We don't know what they are, but the slope of RH, we're going to have to do 6 minus y over 11 minus x, and we're going to have to get 0. Now, whatever we do to get 0, it's going to be because we make the numerator 0. So this is going to have to end up being 0 over some number. We don't know nor care what number it is. But we just know that this difference has to give us 0. Well, if that's true, then that means that y has to be equal to 6. All right, so if this is equal to 0, then this means we can conclude y equals 6. Oops, sorry, I just wrote y equals 0. Y has to equal 6. Right. Again, as long as we don't pick 11 for x, we're fine here. But I don't think that would be possible, because this is 11. We can't be at 11 all the way over here, too. Again, think about this. This is on an xy plane, so this is the point 3, 2. So we're somewhere right here. All right, 1, 2, 3, 1, 2. So R can't, the x coordinate of R can't also be 11. So there's no concern about that. We're just saying that the y coordinate has to be 6. All right, now let's look at this set of sides right here. So the slope of HO. So again, notice I'm always doing the known one first, the one where we know both sets of points. All right, so we do the difference in the y coordinates. That's going to be 6 minus 2 over the difference in the x coordinates. That's 11 minus 8. All right, 6 minus 2 is 4. 11 minus 8 is 3. All right, so then that means we have to make this have the same slope as well. So then the slope of RM. Now I already know that y is 6, so really I could go back and fill this in, because we're going to need that point when we figure this out. So I'm going to do the difference in the y coordinates, so 6 minus 2 again, and then x minus 3. All right, so 6 minus 2 is going to give us 4. All right, this tells us that we need, all right, this is going to be x minus 3, sorry, and we need that to be 4/3. All right, the numerators match, which means that the denominators also have to match. So basically what we can just do is come over here and say that x minus 3 has to equal 3 in order for us to get 4/3 as our answer. And so when we solve, we get x equals 6. All right, so the ordered pair that makes up R would be 6, 6. Okay, so then Now it's saying, okay, if that's the ordered pair that we say it is, let's prove that this is actually a rhombus, that RHOM is a rhombus. So again, if you go back to that sheet on page 188, it looks like this, and we're trying to prove that a shape is a rhombus. What we need to do is show that all sides are congruent. And again, we do congruence with the distance formula, so we're going to have to do 4 sets of distance formulas to show that all of these sides have the same measure. All right, so let's start with RM. And we're going to do the distance formula. Again, you don't technically need to do it for this one. Let's just do it for this one. And here we won't do it. We'll talk about the distance formula here and then say the shortcut, and we'll use the shortcut here. So RM, again, distance formula says the difference of the x coordinate squared plus the difference of the y coordinate squared, and then that take the square root of that sum. So if we take the difference of the x coordinates here, it's 11 minus 6 squared, and then the difference of the y coordinates, that's 6 minus 6 squared. 11 minus 6 is 5, so we end up with the square root of 5 squared, which is 25, plus, and then the difference of the y coordinates is 0, 0 squared is 0, so we end up with really square root of 25, which is 5. Right, so the length of that side is 5. Now, when I'm saying that there's a shortcut, since these are on the same horizontal line, the y coordinates are the same, really it's just going to be the difference between the x coordinates. All right, so take the larger x coordinate minus the smaller one, that's going to tell us how far apart they are. If it were tilted like either of these two sides, we wouldn't have a choice. We would have to use the distance formula. But when it's a horizontal line or a vertical line, you just can count how far apart they are. So when we get down to this one, we won't do the distance formula. We'll just kind of use the shortcut there since it's a horizontal line. Okay, HO. This one we have to because the line is slanted. All right, so difference between the x coordinates, so 11 minus 8 squared, plus difference between the y coordinates, that's 6 minus 2 squared, all under the square root. Oh, I hear our little kitty friend coming in. Okay, 11 minus 8, that's going to be 3 squared. So it's going to be 9, plus 6 minus 2 is 4. 4 squared is 16. 9 plus 16 is 25, so square root of 25, that's 5. Okay, off to a good start. So far we've shown that our first two sides both have the same length. Now again, for here, MO, I'm just going to do the shortcut there and say, since this is a horizontal line, I just have to find the distance between the x coordinates. So it's just going to be 8 minus 3 is 5. Again, feel free to keep doing that just for the practice, use the distance formula, just so that you get comfortable with it. But really, we don't need to do that. We can just do the distance between the x coordinates. All right, last side, MR. So here we have to use the distance formula. I'm going to do the difference between the x coordinates, 6 minus 3 squared, plus the difference between the y coordinates, 6 minus 2 squared. Add them together and put them under the square root. 6 minus 3 is 3, squared is 9. 6 minus 2 is 4, squared is 16. So we get the square root of 9 plus 16, which is the square root of 25, which is 5. All right, so what we're going to do here is we're going to say we showed that all 4 sides of quadrilateral RHOM are equal in length. Therefore, RHOM is a rhombus. Okay. All right. I'm going to move on to problem number 3 in the next video.